Hi, everyone. This is Sebastian Traeger, Managing Director of Reliability.com, and welcome back to another Reliability 4.0 episode. As always, we're on a mission to help make the world a more reliable place. And today we are joined by Ali Walsh from Australia. She'll talk about that in a little bit. But Ali is the head of asset strategy and insight for SA Power Networks. And Ali, we are so grateful for you to be with us. Thank you for joining us today.
Thank you.
Tell us a little bit about the company, SA Power Network, and what you all do and where you all are located.
So SA Power Networks is the sole electricity distributor in South Australia. So South Australia is the central southern state in Australia. So not the East Coast that most people are familiar with, not the Melbournes and Sydneys. We're in Adelaide based in the centre of Australia. SA Power Networks covers 99% of the population of South Australia with electricity distribution, supplying about 900,000 homes and businesses across one of the kind of longest, skinniest networks in the world. We have an incredibly high penetration of rooftop solar, which puts us right at the forefront of the energy transition. And we are second only to Denmark in the proportion of variable renewable generation that's on our grid, with a lot less interconnection than Denmark has, because we're right at the end of the national electricity market in Australia.
Okay, so you said you're one of the longest and skinniest networks. What does that mean exactly? Like, where do you go from and to?
Yeah, so we go from the border with Victoria all the way out across the Eyre Peninsula to Ceduna. It's a network route length of nearly 90,000 kilometres, covering an area of nearly 180 square kilometres. So our furthest points are many, many hours drive from the nearest depots, and so certainly provide some reliability challenges in some of those remote areas.
Now, I'm from North America, from the United States, as are, I think, a lot of our listeners. And we have to admit, we don't know Australia geography as well as we probably should. But you're kind of south. What do you usually describe the shape of Australia to be?
I don't know.
It's kind of like a football sort of shape.
Yeah.
And you guys are about
in the middle, south.
All the way in the south. About, you said 2 hours from Sydney, about 3 hours from Perth on the other side.
Yeah, right in the middle.
You know, just out of curiosity, are there like local competition between your city compared to Sydney, compared to Melbourne? Like, how does that all work?
Yeah, definitely plenty of argy-bargy between the different cities. Adelaide is one of the most livable cities in the world, but Sydney and Melbourne certainly think they're the bee's knees.
That's great. That's good. Well, I'd love to learn more about that, but we're going to dive into reliability engineering instead. So tell us a little bit about your role and how you kind of came to become asset strategy. That's a big job, obviously, very important one. How did you get there?
Yeah, so I'm head of asset strategy and insight, and I've been working on my elevator pitch. And I think the kind of the one-line version is that our job is to make sure that we make decisions that stand the test of time. So what we want is people to look back on the work we've done and say that, you know, those were good technical standards, they were good systems, they were good decisions that you made. You made the right decisions with the information you had, and, you know, we're grateful for that work. So asset strategy and insights is my role. And insights is really about making sure that we know that we're making the right decisions and we're able to test the decisions that we make. And ultimately, if we get it wrong, it ends up costing customers through poor reliability and poor safety outcomes.
It's good. And in your background then, did you kind of grow up thinking this is what I want to do? Or was that kind of a more evolutionary process?
Well, it's interesting, actually. I did work experience as a teenager with our transmission and network service provider, and got the opportunity to see their control room, the electricity control room, and then I studied electrical engineering. I came into SA Power Networks as a graduate engineer over 10 years ago now, rotated around, got to learn all about the business, worked a little bit in our substation design group. And then after I had my first son, I got the opportunity to run our network operations group, which was pretty exciting. So that's our control room, our switching planning, but also our reliability operations group. So the group that check on outages and see if we can continue to improve the reliability of our network. It was really quite fun when I got that role, because it came kind of full circle from my work experience as a teenager, being in the control room of the transmission provider. And then now I was running the control room of the distribution provider. And then after my second son, I got the opportunity to move into the asset management space. So initially running the asset management transformation program, so trying to really uplift our asset management capability in the business. And then now, after an organizational op model reshuffle, I got the opportunity to run asset strategy and insight. So that really
That's great.
Far-looking, long-term asset strategy.
It's great. And I mean, that sounds like, I love that journey that you've been on and how it sounds like you've just done good, excellent work at every step of the way. And so you get another opportunity to have a little bit larger, breadth of responsibilities. So that's a neat story. I think doing really good work at each stage is sort of underrated in the professional world, and how it's like, if you do that, you kind of get more responsibility.
The advantage of spending time in a company too, and moving around and being a graduate and rotating around, is you build that really strong business acumen that serves you well, particularly in the asset strategy space. Often we have kind of really young engineers or first year graduates come into the asset strategy space, and they struggle a bit because they don't have the kind of broader context that you need to do asset strategy really well.
That's great. Well, you recently spoke at a conference there in Melbourne, the Mainstream Conference. Could you give us a quick overview of that session and kind of the main ideas you discussed?
Yeah, so we were talking about data overload in that panel discussion. And it kind of really spoke to me because I chair our Data Governance Council at SA Power Networks. And it was a real opportunity to share the importance of data governance. If you can trust your data, if your data is correct and available and high quality, then your ability to make good decisions based on that is just enhanced significantly. And so some of the key things I really wanted to share at the conference was associated with the work that we had done in the asset strategy team of bringing data analysts and data scientists into our team. So we had a few roles open. All of them were asset strategy engineers, but we made the decision to actually, rather than hire an asset strategy engineer into one of them, to hire a data analyst. And it's been hugely valuable. They bring a different skill set, a different thinking, and they really unlock some of the value of that kind of big data analysis. And when you combine them with that engineering thinking, you can unlock kind of the world of possibilities in terms of making really good data-driven decisions.
So just so I'm clear, you basically talks about data overload. I think all of us have been part of a situation where we want data, but we don't trust it. Your solution to the problem was, hey, let's actually hire somebody whose sole job is presumably making sure the data is as accurate as it can be. Obviously, there's always going to be some data that's just a little dirty, and then analyzing that data as well.
What we've hired into our team is less about fixing the base data. We've still got that problem and we still need to do it. The data scientists that we've been able to make use of have been able to deal with what is there and really get the best out of it.
Yeah, less about how do we go back and fix it all, and more how do we kind of ignore or fix the data that's inaccurate and eliminate that noise.
Yeah. And look, we've got kind of multiple paths that we're working on. We're working on making sure that we call it stop the bleed. So get better data from now moving forward. Once we can do that, working on making sure that we can improve the data that's there in a way that's in our core systems rather than polishing it for one particular task and not actually updating it in our core systems. But then also, how do you deal with the fact that we have what we have and how can we make the best decisions with that and fill in blanks? So our data scientists have done cool things when we're we only have this set of data for vegetation. And they're well, actually, there's a bunch of publicly available information about vegetation. Yes, this company does satellite stuff, or actually I can fill in a bunch of the gaps of that data that you think you've got a data set that's this big, but actually I can access a data set that's much bigger and fill in a bunch of gaps and know whether or not it's accurate without you having to go and actually send someone to look at all those trees again.
Right. That's fascinating. Interesting.
Yeah. And it's the really wonderful, different thinking that a data scientist has brought to our engineering team, who are well, this is what I've got and I'll make the best of it. Well, actually, I can do more than that.
Now, that's interesting because you obviously have more of an engineering background, which isn't obviously data is a part of that, but I would not say data science is necessarily. How did you grow an appreciation for that? Is that through reading, through looking around? There was a natural component to that? How did that come about?
Yeah, so I actually do have a computer science degree as well, though it's
Oh,
been
wow.
a while
Okay.
since
Well,
I used it. I also have a genetics degree, but I don't use that much these days. The kind of value of data science actually has come through some of my leaders and my managers. So one of them is particularly good at kind of keeping up to date with all of the kind of AI, future tech
right.
stuff. And he's the one who said, actually, I think initially he hired a graduate data analyst into his team. So did it by stealth. So said, oh, here's a data analyst. Oh, here's all the wonderful things they can do. And it's like, well, that's really handy. And then suddenly you're like, can I have more of them? It's like, yes,
Right.
here's a data scientist. So one of my knowledge and insights manager, actually, so kind of well positioned for that. Knowledge and insights, he's really said, well, I can get more insights from these data skills. And that's, really opened the engineer's eyes.
That's great. I want to shift directions a little bit, still in the data world, but we often think a lot with our customers about what their KPIs are or goals, however you want to frame that. Given that you are so data driven, I'm assuming on the asset side, how do you think about your KPIs and what are those metrics that you think are the most valuable, especially for reliability engineering and asset management to be thinking about?
So we've worked quite hard over the last couple of years on kind of improving and clarifying our asset management objectives. And the really key thing about our asset management objectives is to make sure they are based on what our customers and stakeholders require. So we've made sure we tested them with our customers and stakeholder groups, and ultimately when our regulators or our customers or businesses or technical regulators or government look at our asset management objectives, they should say, yes, that is what I want you to do. So our asset management objectives come in 6 key themes, and kind of 3 of them are kind of what our customers called like expected. So safety, reliability, and compliance. And so safety for us includes both safety of the public, safety of our people, but it also includes our bushfire safety. We have quite a high bushfire risk in South Australia, and therefore a lot of our kind of decisions that stand the test of time is really decisions that don't cause a bushfire or wildfire in American language.
Right.
Reliability. So obviously most of people want to just flick the switch and the power comes on. They don't want to have to think about it. And when the power does go off, they want to know when it's coming back on. And compliance, obviously, again, that kind of stand the test of time. The rules exist for a reason, generally safety or reliability reasons. And then the other 3 themes around sustainability. So making sure that our decisions are environmentally and socially responsible, customer experience. So kind of reliability, power on, customer experience, tell them when it's going to come back on when it goes off, and making sure that customers can access things like access the grid for exports, for the energy transition, those kind of things. And then commercial, making sure that the decisions we make will not put us in a poor commercial position in the long run, but also to that, ultimately we are spending our customers' money. And so how do we make sure that every dollar we spent is spent as best as possible? So our asset management objectives fit in those 6 key themes: so safety, reliability, compliance, sustainability, customer experience, and commercial. The work that our corporate strategic group have been working on objectives and key results. And so how do we be really clear on what we're trying to achieve and what the key results are? One of the key things that we are working on in the asset strategy team is risk removed per dollar spent. And so the ability to quantify in dollar terms what the risk is. So what is your bushfire risk in dollar terms, or safety risk in dollar terms, reliability risk in dollar terms associated with things like the value of customer reliability, what is the actual environmental costs of failure of an asset, or the value of customer time in the customer experience. Like if you can do something that saves them time, then there's a value to that. So trying to quantify all of that in order that we can be sure that every dollar we spend is removing as much risk as possible from the network. Safety and reliability risk tend to dominate when we put those all together. So reliability risk mostly, and then safety risk mainly around that bushfire risk.
So let me try to understand it and help folks understand. So let's say you have 100% is ideal, right? No risk whatsoever. There's always going to be some risk in the system, right?
So it doesn't exist for an electricity network, but okay. Yep.
Right. But let's say, I don't know, there's 2% chance that power will go out for a day. I don't know. I'm making these kind of numbers up, right? So then you have to figure out what's the cost of a day of outage?
Yep.
And then effectively say, okay, so now we know a 2% risk, 2% times whatever that cost is. Yep. We know the value people theoretically would pay to reduce that risk by 1%.
Exactly. So our asset strategy team with our strategy engineers and data analysts calculate the probability of failure. So the probability that the power will go out, the cost of consequence, so how much it would cost, both from a value of customer reliability and those other areas, and then the likelihood of that consequence. So,
Okay.
And then they times them all together to get a risk value.
Okay. So you've got that risk value. And so then do you kind of have like, here's the 20 things we could do, here's what they cost to do them, and here's the impact they would have on that risk, and then just kind of say 4 above the line, so we should do them, and 16 just aren't quite there, so we're just not going to do them yet?
Yeah, that's the idea. With hundreds of thousands of assets and multiple different decision points and variable levels of data, but that's what we're working towards. Yeah, so I've got, it's like 600,000 polls. Which poll is the most likely to fail? And if it were to fail, what's the consequence? So there are some polls that you want to replace because their probability of failure is really high, but the actual consequence associated with them is quite low. So they're a non-bushfire risk area, they're only supplying one customer, but the probability of failure is high enough that you kind of want to replace it anyway. And then other polls where perhaps the probability of failure is not as high, it might last 10 years or it might fail in the next 2, but the consequence is really extreme. So if that poll were to fail, we would lose, tens of thousands of customers or start a bushfire that could, do millions or hundreds of millions of dollars of damage. That poll should be replaced within the next 3 months. And that poll that's really likely to fail, that one should also be replaced in the next year. The kind of idea is you build this kind of perfect crystal ball and predict exactly when everything will fail.
Right, of course.
And you replace it like 2 days before it fails, right? To give yourself a little buffer so you get no safety consequence, no reliability impact, and no poor customer experience. The reality is obviously the models we're talking about are statistical models, so they're not that right. Good. Even if you had perfect data, statistical models still say it'll fail sometime in the next X, and obviously our data is far from perfect. But that's the idea. We're trying to build a crystal ball and continually enhance and refine that crystal ball to make better and better decisions.
Well, a lot more we could discuss about data and how you're using that related to kind of predicting polls and things. I do just want to shift the conversation a little bit. Our company helps people with root cause analysis. So I would love to hear what you all do around root cause analysis, your process, how you're using data, what effectiveness you're having with that.
Yeah, so we've got investigation processes that we use to investigate various different sorts of failures. So we make a point of investigating every fire start, equipment failures, those kind of things, and significant reliability things as well. Like we have outages every day, so we don't investigate in detail every single one, but certainly anything that caused a significant impact. We're working to improve the feedback loops in how the data that comes out of those investigations feeds back into our decision making. It's one of the things that we're looking to enhance in our asset management, how we keep improving that.
Well, that's great. That's great to hear. And so that's just something you're continually working on and trying to figure out. But again, it sounds like with so much data that you're working with and just how advanced you guys are getting, I look forward to hearing how you do that.
We do quite a good job with things like pole failures, but we're less good at our linear assets. So things like conductors and cables, where it's harder to tell exactly kind of where a failure, like is the failure a failure of the whole section or just a part of the section? And so we're working on improving how we divide up our linear assets in order to attach failures better to those assets in a way that allows us to make better decisions moving forward.
Right. So you're not just analyzing just that one asset, but thinking, how does it relate to the entire system? That's good. As we wrap up, I just like to always ask folks, is there any kind of one thing you want to kind of pass on to folks that you've learned? I mean, you've had such an interesting career. I mean, just the fact that you've done genetics, computer science, and are now doing kind of reliability engineering and specifically have kind of a data scientist on your team. Is there any kind of one last piece of advice or expertise you'd want to pass on?
Probably 2, and they're kind of interrelated. So one is the value of the data scientists, and the other is around like the future's already here. It's just not evenly distributed. So if you're able to access people like data scientists who are forward thinking and able to tap into the kind of pockets of excellence that are out there, you're able to bring those kind of pockets of the future to you now and therefore take advantage of them.
That's good. I like that. I like that way you said that. The future is not evenly distributed. So effectively, you can get the more on the cutting edge, the more you have some folks on your team who are kind of thinking that way
Yeah.
and start to take advantage of that. That's great. That's a great final word. We obviously heard you talk a lot about data scientists, so that was great. Well, Ali, thank you so much for being a part of this. We really appreciate it. Again, this is Ali Walsh. She's the head of asset strategy and insight at SA Power Networks in Adelaide, Australia. So it's great to have you on. And to all listeners, we're really about helping engineers and really anyone learning to take steps to be more successful at leveraging technology, leveraging data. I like how Ali just put it, kind of leveraging the future to bring solutions today. If you're out there and you're looking for root cause analysis training or resources and materials, please check out reliability.com. If you're looking to go deeper, think about using our software, Easy RCA. But really, we just want to empower you all to make good decisions, to be thoughtful at what you're doing. So that's all the time we have today. Again, Ali, thanks so much for being on it.
Thank you.
And thank you, everybody out there, as we work together to make the world a more reliable place. Again, this was Sebastian Traeger, and we will see you all on the next episode. Take care.